Okay, today we're talking about Chapter 3, Section 3, the point slope form. So again, we're going to have another, we jump straight to examples here. We have another equation that you have to memorize. All right, so let's give this its own page real fast. So in Section 3.2, we graph lines using the y-intercept and the slope by moving vertically and then horizontally. All right, again, the rise of the run or the fall or run backwards or something like that. From our y-intercept. This same technique can be used to graph lines if the given point is on the line but not the y-intercept. So we're going to consider the following example. Um, let's actually, yeah, you know what? Let's actually put this. Let's actually snip this. All right, so we are tasked with graphing the line with slope m is equal to -3/4, which passes through the point 2,5. Okay, so we have our slope -3/4, and then we pass through the point 2,5. And I mean, yes, I could have graphed it, but I mean, it's just a lot easier if I do this. I know. Hopefully you don't think I'm lazy because I do a lot of computation. It's just I know my graphs can be kind of bad. But with that said, you start here at the point 2,5, which is over 2 of 5. You start here at this point up here, and then you take the slope, which is -3/4. So you would, in this particular case, you can't necessarily rise, right? There's no room to rise. So we're going to do fall and run to the right. So we're going to fall 3 and run to the right 4. And we see that we have that 0.62, and then we can connect those lines and create our line. Right? So there's obviously a point to why the textbook wanted to go over that again. But the main point we want to talk about is the point slope form. Right? And this is more or less the proof of the point slope form, and there's nothing wrong with it. But I know that as students, you care more about, show me the example, show me an example, show me an example. So this will be here for you if you need it. Let's see, can we fit that here? No, yes, no, maybe. Barely. Okay. And the big one is just the point slope form. Now, the slope-intercept form is named. Well, hang on, before I get into that, okay. So let's go ahead and snip this while I'm here. Whew, all right, here we go. So the slope-intercept form. Okay, we don't actually have it right now. We don't have an example here, but it was on 3.2. The slope-intercept form is aptly named because in that equation you see the slope. Okay, because again the equation was y is equal to mx plus b. This is called slope-intercept because we have the slope given to us and the y-intercept. Okay, so we call it the slope-intercept form. Pretty easy to remember. The next thing we talk about is the point slope form. Now the point slope form, we're looking right here. All this again is just basically kind of a proof to go from my slope, and then we get to the point slope form. But over here is the thing that you care about. The point slope form is aptly named because you use a point, x1, y1, and the slope, which is which is m. So you use the slope, use the point, and use the slope for the point slope form. So let's put that into practice. Oh, I already snipped it. Let's put that into practice. This reads, find the equation of a line with slope of -1/2 and which passes through the point 2, 3. Okay, so looking at this, we'd say, okay, so I have a point. I'm given a point right here, and I'm given a slope. So I must use the point slope form. So let's go ahead and write the point slope form again real quickly. So y minus y1, and that's equal to m times x minus x1. Okay, so we're given a point. Let's put this off to the side here. So my point is 2, 3, and my slope is -1/2. So what I'm going to do is I can just basically fill in the blanks here, okay? So by filling in the blanks, this y is going to come down, okay, because it is just a y. This x is going to come down because it is just an x. What I have to fill in now is I have to fill in the y1, x1, and the m. That's it. Okay, so it becomes y minus y1. So what is the y value here, which is 3? So it's going to be y minus 3. And then my slope is negative 1/2. So negative 1/2. And of course, that parentheses stays there because this is coming down with it too. And then minus, what is the x value here? What is 2? Okay, and I hesitate to say, but that's it, right? I mean, at this point now we have to, it says find the equation, so we have to solve for y, but that's it. So let's go ahead and solve for y, and we'll probably, let's see if I can't, I kind of want to put this all on one page, if I can help it. And let's see, let's make red arrows going down. And I mean, those are the only two that come down. Everything else get replaced. So solving here, I'm going to do some just some quick mental math here. So we have a y minus 3. That's going to be equal to a negative 1/2 x. And then negative 1/2 times the 2 is a positive 1, so plus 1. And then we solve for y, so we're going to add 3 to both sides. So we're going to have y is equal to a negative 1/2. We add 3 to 1, so it's plus 4. Okay, and that is the equation of the line. And oh, it says graph. Okay, so we want to graph it, and we're going to go ahead and snip the graph here. Which one of these graphs do I want? Why not both? I think we can fit both. Ooh, can we? Now we're going to do a little bit of squishing here. There we go. All right, so the way it's graphed, obviously, I mean, you have your point, which is at, let's see. Oh, I see what we're doing. Okay, so in the first graph, it's using the point 2, 3, and we are using the slope of negative 1/2. We go down 1/2, and we can connect the lines. Or, since we created the equation of a line, we can go up here to the y-intercept, which is at 4, and then again, my slope, which is down 1/2, and it creates the same line. So it's two ways to find the graph, and it's two methods that we have talked about. Well, in the past two sections. Okay, so finding the equations of lines given 2 points. So now we're gonna have to think a little bit about our problems here. All right, we're not just given a problem to solve. So what do I mean by that? Given 2 points that lie on the line, the equation of a line can be found by using the following method. So we can find the equation of a line by first finding the slope between these two lines, and then using the point slope form. That's pretty easy, right? So let's go ahead and do that. So example 3, find the equation of a line containing 2 points, negative 1, 2, and 4, negative 2. So I need to find the slope. So my slope is going to be the change in y, or the change in x. So I'm going to do negative 2 minus 2 all over 4 minus a negative. Okay, we're just getting dot ones. Negative 1. There we go. Okay. Well, 2 minus a negative 2, well, that is a negative 2 minus 2, which is negative 4. And then a 4 minus a negative 1, so that's a 4 plus 1, which is 5. And then negative 4/5, well, that's just going to be put the negative out front, negative 4/5. Okay. So we have a slope of negative 4/5. Now we have to find the equation of a line. So to find the equation of a line, we need to use the point slope form. Well, in this particular case, we do have the slope. That's easy, but we have 2 points here. We have 2 points. Okay. Well, the thing is, it doesn't matter which point that you use. You could use either point and it will work. And so let's just choose one. I like to choose the smaller numbers if it's given to me, the smaller numbers or the positive numbers. In this particular case, they both contain a negative, so it doesn't matter what. But I'm going to go ahead and use -1 and +2. So again, we have our equation, my point slope form, which is a y minus y1 is equal to mx minus x1. And again, the y's just come on down. So we have a y, and then we're going to choose, like I said, we're going to choose this point here, -1, 2. So we're going to say y minus 2 is equal to m, which was a -4/5, and then x, which is a -1. I'm sorry, x comes down, minus a -1, like that. Okay, and again, I'm super redundant with my parentheses because I have to be, right. I don't want to make the mistake of missing a negative somewhere. So I end up with a y minus 2 is equal to a -4/5 x plus 1. Fix this up a little bit. Y minus 2 is equal to a -4/5 x minus 4/5. And then we're going to add 2 to both sides. So we're going to end up with a y is equal to a -4/5 x. And then if we add 2 to both sides, well, 2 with the denominator of 5 is 10. So we're going to have a 6/5. So plus 6, and I got a toolbar here I got to move for a second. Fifths. Okay, that is using the first point, -1, 2. And I'm going to snip the second one so it'll fit. And that's the second one. Okay, so what I did in the blue is using the point -1, +2, and this is the point for -2. And of course that's just nice and neat. So yeah, we just have to kind of expand our brain a little bit and use our mind on trying to figure these out. So this one, okay, so I don't want to snip the solution here. Maybe I can do something kind of cool here. So give me a second. Let's see if I can do this. No, not necessarily. Well, I guess I could. Hang on, give me a second. There we go, this way. And there we go. All right. So this wants us to write the equation of a line, or write the equation for this particular line. Okay, so it's not too difficult to look at. If we want to write the equation of this line, we'll go about this a couple of ways. But I think the book wants us to use the point slope form, although we could just as well. Well, no, we can't actually. I was going to say we could use the slope intercept, but as you can see, I mean, you might not be able to, yeah, you can. It's high def. We're not actually on 6. We're like at 6.4 or something, right? Something I don't know. So we are going to have to actually use the point slope form. But in order to use the point slope form, I'm going to need some points and a point and a slope. Well, one of the points looks to be, I mean, is that before 5? I'm looking here because I need to get a very concise point here. looks like it's coming down before the 5. I don't know. Which one of these points are they wanting us to use? Interesting. It does. I mean, I guess it is kind of going through the 5. I don't know. Oh, right here. Okay, right here it looks like it's going through -1 and 5. And let me, you know what? Let me actually just blow this up real quick because I really don't want to mess this up. Oh, that's not right. Okay, so yeah, I can't use the x-intercept because we're crossing right before the 5. I can't use the y-intercept because we're crossing above the 6. It looks like this one might be the point that I use. So it looks like -1, +5. So -1, +5 will be my point. So let's go ahead and write that before I forget. So my point, wow, okay, my point is going to be -1 and +5. Okay, now I need a slope. So my slope, I probably should have left that zoomed out, huh? Let's check that out again. So all I have to do is figure out rise of a run to find my slope. And looks like well, it's actually kind of hard to tell. I mean, maybe this one. All right, this example is certainly not my favorite because I'm only seeing one point that I can really positively say that it's a point. I'm actually not even sure that that's a point, but it's the best point I have. Maybe because the line keeps going. Maybe 2, 9. Let me just see what the textbook's saying here. Oh yeah, okay, yeah. So 2, 9 and -1, 5. Okay, so well, it's not readily apparent that 2, 9 is there, but whatever. So the other point that is on the line that it's hard to tell is 2, 9. So I'm gonna find the slope here. So I'm gonna say 9 minus 5. Again, I'm doing change in y. 9 minus 5, and then 2 minus a negative. I just get dots everywhere. Minus a -1. Okay, so 9 minus 5. Well, that is a 4. 2 minus -1 is 2 plus 1, which is 3. So I have a slope of 4/3. Okay. So I have a slope of 4/3 and my point. So now I have the point slope. I'm sorry, I have a point and I have a slope, so I can do the point slope formula. So I'm just going to go ahead and write y minus, and then y1 is 5, is equal to m, which is 4/3, and then x minus x1, which is a -1. And then we clean this up, we end up with a y minus 5 is equal to 4/3 x, and the 4/3 and x minus -1 is x plus 1, so it's just going to be plus 4/3. And then we add 5 to both sides. 5 with a denominator of 3 is 15, so we get y is equal to a 4/3 x, and then 15/3 plus 4/3 is 19/3, so plus 19/3. Okay, so that's interesting. So the y-intercept, I remember if you recall, like 10 minutes ago, I said, oh, we use the intercepts. Well, I said we're going barely above the y. I'm sorry, we're going barely above the 6. Well, 19/3 is 6 1/3, so we're actually going 1/3 above 6. So yeah, we were not able to use the y-intercept there. Ooh, that wasn't my favorite problem we've done, mainly because it was just really hard to see. Alrighty, so next up we have parallel and perpendicular lines. Parallel and perpendicular lines, you've heard of them before, you probably know them already, but we're going to talk about them anyways. Parallel lines are lines that never intersect and who have the same slope. Pretty easy. They're lines that never intersect. Perpendicular lines, are lines that intersect at 90-degree angles. They have got to intersect 90-degree angles, and whose slopes are negative reciprocals of each other. So let's go ahead real fast and talk about what negative reciprocals mean. All right, so looking at this particular graph, we have, this is just a perpendicular one. We have a slope of, the blue line, the slope is 2/3. Well, the negative reciprocal is basically just the negative of 2/3, which is, negative 2/3, but then you flip the fraction. So instead of 2/3, it's 3/2, so negative 3/2. And that's what negative reciprocal means. You just change the sign. If it's negative, change it to positive. If it's positive, change it to negative. And then you flip the fraction around. And that is how we can determine if the slopes are negative reciprocals or not. Okay, so let's do this. And again, these next few examples, and this section in general, especially when it comes to problems like this, where we have to incorporate a lot of the things that we've learned in previous sections, and we're not necessarily told equations to go about it. We just have to kind of figure it out. So let's figure this out. It reads, find the equation of a line through the point 3, 2, and it is parallel to the line 5x plus 3y is equal to 1. So I have to find an equation of a line, and it passes through the point 3, 2. Okay, and it is also parallel to 5x plus 3y is equal to 1. Well, in order to be parallel to it, I must have the same slope. So in order to have the same slope, I must find the slope. So let's find the slope of that equation. So I'm just going to go ahead and immediately subtract 5x from both sides. So I'm going to have 3y is equal to a negative 5x plus 1. And sometimes since I'm not in a classroom, it gets kind of, what am I trying to say? I do things sometimes and I don't realize it. So up until now, I don't know if you've noticed or not, but I'm taking these equations and I'm immediately doing the first step when I write it. So I subtracted 5x on both sides, and that's what I did here, 3x minus 5x. And I've done that for well, I don't know, every example I think I've done in this class so far. So here we are midway through the semester. Hopefully I haven't lost you at some point along the way, but that's what I do. Anyways, next thing we're going to do is we're going to divide both sides by 3. So we're going to have a y. Let's put this in blue. Y is equal to negative 5 divided by 3 is a negative 5/3 x. And then a 1 divided by 3 is just simply a 1/3. So this particular equation has a slope of negative 5/3. Okay. So in order to create an equation, I must use um, point point slope form, and luckily we were given a point, so that's good. Now we have the slope, so we can officially use the point slope form. So my point slope form is y minus y1, and y1 here is a 2. Again, I'm looking right here. It's a 2. So y minus 2 is equal to my slope, which is a negative 5/3, and then x minus x1, which is a 3, and again that's this 3 right here. And then we can clean this up, so we've got a y minus 2 is equal to a negative 5/3 x, and then 5/3 times a negative 5/3 times a negative 3 is a positive 15/3, or a positive 5, so plus 5. And it looks like we're going to add 2 to both sides. We're going to have y is equal to a negative 5/3 x, and 5 plus 2 is 7, so plus 7. Okay, and we're going to snip the slope here, or not slope, but the graph here. And of course we can see that we were indeed correct. So the blue line is this equation here, 5x plus 3y is equal to 1. And the green line is the line that is um, parallel to it, using the 0.32. All right, next up we're going to do perpendicular. Now perpendicular, well, honestly the steps are pretty much the exact same, except this time I'm not going to be using the exact same slope. I'm going to be using the negative reciprocal. All right, so is this the same equation, 5x plus 3y? Yeah. So 5x plus 3y was, y is equal to negative 5/3 x. So I think it was plus 1/3. Okay. Okay. So this was, again, the equation of uh, my, I'm sorry, this is this equation solving for y so I can figure out what my slope is, negative 5/3. Well, if I want to have an equation that is if I want to find a line that is perpendicular to this line here, then I must have a line that is the negative reciprocal. Well, if this is a negative 5/3, well then to get a perpendicular slope, so we're going to write perp slope is going to be the negative reciprocal. So instead of being a negative, it's going to be positive. Instead of being 5/3, it's going to be 3/5. And then we just do the point slope form again, right? So we're just going to go, and we'll put it in red, I guess. Y minus y1, which is a 2, is equal to 3/5. Again, that's a slope. And then x minus x1, which is a 3. It's x minus 3. And then we've got y minus 2 is equal to a 3/5 x. And then 3/5 times a negative 3 is going to be a negative 9/5, so minus 9/5. And then we're going to add 2 to both sides. So we're going to have a positive 3/5 x. And then if we add 2 to 9/5, well, 2 with the denominator of 5 is 10, so it'd be 10/5. So we're adding 10/5 to both sides. So we're just going to end up with a plus 1/5. Okay, and that's it. So let's go ahead and snip the graph again. And we can see that, oh, I did it in blue. Nice. So in the blue is my, 5x plus 3y is equal to 1. And in the green, past the 0.32, we do indeed see that we create a line that is perpendicular. Right. Was that it? Okay, that's it. And this is humongous, humongous. Uh, Obviously, watch these lectures, take notes, do the homework. But this is the biggest deal here. Make sure this is in your head. So that does conclude today's lecture.